So the chapter we're going to be learning about today is going to be the heart.
The next topic of discussion is the sequence of depolarization and repolarization of the heart related to the ECG, otherwise known as EKG, waves. Let's begin with the P wave, which is here in the green. Atrial depolarization initiated by the SA node causes the P wave. Next, here in the red, we're at the end of the P wave. With atrial depolarization complete, the impulse is delayed at the AV node. Then we have the QRS wave, which is here in the red. Ventricle depolarization begins at the apex, causing the QRS complex. Atrial repolarization occurs.
So now we're going to start with the pre-T wave. Ventricle depolarization is complete. You see it on the red, number 4. Now, this is the T wave, right here with the red, number 5. The ventricle repolarization begins at apex, causing the T wave, right here. Now, this is the post-T wave, which it's after the T wave, number 6. Ventricle repolarization is complete.
Okay, so today we're going to be talking about the clinical problems of the heart. First, we have tachycardia. So that's fast heartbeat, meaning anything that's over 100 beats per minute. Then bradycardia. So your heart rate is too slow, meaning that it's anything under 60 beats per minute. And then atherosclerosis, which is very difficult to say. So then we have, it's anything with plaques or buildup in the vessels. Then you have congenital heart failure. So your heart can't pump enough blood to keep up with the body's demands. Then you have congenital heart defects. Cyanotic means that the baby turns blue, but then acyanotic, your baby comes out pink. So just be careful not to get these two mixed up.
Let's discuss the intrinsic cardiac conduction system, sequence of excitation. In simpler terms, this sets the basic rhythm of a beating heart. We start with the SA node, which is the pacemaker, and it generates the impulses. Then we go to the AV node, the impulse pause, followed up by the AV bundle, which connects the atria to the ventricles, and then we go to the bundle of branches, conducts the impulse through the interventricular septum. Last, we have Purkinje fibers, depolarizes the contractile cells of both ventricles.
Of the heart. Arrhythmia is miscommunication between the atria and ventricles. Then fibrillation is miscommunication between the cells. Then junctional rhythm is SA node fails and the AV node sets the pace. Next is ectopic focus. Someplace other than the SA node is controlling the heart. Heart block. AV node is damaged and needs a pacemaker.
Okay, so today we're going to be talking about the blood flow through the heart. Okay, so in our diagram, the blue represents the oxygen poor and then the red represents the oxygen rich, just so you guys know. So here we start off with the superior vena cava, inferior vena cava, and coronary sinus. All 3 of these lead into your right atrium, and then you go into your tricuspid valve, then your right ventricle, your pulmonary semilunar valve, your pulmonary trunk, your right and left pulmonary arteries, and then you end up in your lungs. Once you're leaving your lungs, you switch over to O2 rich. So now that we've switched over to oxygen-rich blood, out of the lungs you moved into your right and left pulmonary veins. From there you go into your left atrium, your bicuspid valve, your left ventricle, your aortic semilunar valve, and then you end up in your aorta. From here, the blood will split into 2 different parts. So you have your coronary arteries, and then from there you go into your heart. But once you're leaving your heart, it's switched over to oxygen poor blood in your coronary sinus, and then it goes all over again. But when you're leaving the aorta and you go to the rest of your body, out of the rest of your body, you switch over to oxygen poor blood into your superior vena cava and inferior vena cava, and then the process starts over all over again. Okay, now that I've taken you guys through the entirety of the blood flow through the heart, remember, this is really important, so pay attention to what I'm about to tell you because it's going to help you out. Don't forget that your blue is your oxygen poor, and then your red is your oxygen rich. Now let's go back to the lungs. You see how here you're in your right and left pulmonary arteries. Once you're leaving, it's your right and left pulmonary, but veins. So remember, arteries and veins. And here it's kind of going all over from the beginning again, right? But you're on your left side of your heart. And then another one, easy one to remember. Remember, you're in your tricuspid valve, in your O2 pore, but here you're in bicuspid valve. So make sure not to get those mixed up. So over here again, right here you were in your right ventricle, but here you're in your left ventricle. Now, I can't stress this enough. This is really important, so go over this part a couple times. Okay, so the next topic is going to be going over the anatomy of the heart. Okay, so now we're looking at the heart, but from the back side. So this is your right and this is your left side. So now we're gonna go, this is your left atrium. Inside you have your fossa ovalis, which is leftover scar tissue from your foramen ovale. Then you have your superior vena cava, your brachiocephalic artery, your left common carotid artery, your left subclavian artery. Pulmonary arteries, pulmonary veins. Remember, a way I remember this is A for artery, so A is on top. And then you have your inferior vena cava. Okay, so now we're looking at the heart from the front. So it's opposite. So this is your right side of your heart. This is the left side of your heart. So remember that. And here we have your trabeculae carinae. Your auricles are over here. Your right atrium that leads into your tricuspid valve. Coordinate tendineae, and this is your right ventricle. And then we have papillary muscle, pulmonary semilunar valve, interventricular septum would be right here. Then we are in your left ventricle, left atrium that leads into your bicuspid valve. We have some more coordinate tendineae, papillary muscle, and then right in here, aortic semilunar valve. We're gonna move up here, and this is your pectinate muscle. So we have your aorta over here, ascending and descending aorta, your pulmonary trunk, so think of an elephant, and then now we're back in the front, so we have your superior vena cava, brachiocephalic artery, left common carotid artery, left subclavian artery. Okay, now we're going to be discussing the layers and tissues in your heart. First, layers. Your outermost layer is your epicardium. Your middle layer, myocardium, and then your innermost is your endocardium. Now for tissues. Your outermost layer and your innermost layer are both simple squamous epi, but your myocardium is going to be cardiac muscle. So just think, obviously this looks like muscle and it has the striation. So when you see that, it's going to be cardiac muscle.
Let's go over some of the artery and veins of the heart. Here you have the coronary artery. It runs right along here. Please note that most teachers would want you to express whether it's the right or left side of the heart. In this case, this coronary artery is on the right side, so it's your right coronary artery. Now, on the back side of the heart, let me take this off. This little inlet right here, this vein is your coronary sinus right here. This part right here is your great cardiac vein. Let me put this back. Another thing to note is that here you have your pulmonary vein. This is O2 rich blood. This here that's purple is your O2 poor blood. So think purple, poor, and think red, rich oxygen blood.
Fly be free!